So our fifth part of our biomechanics topic, we're looking at base of support, and that relates with centre of gravity and overall balance. So what there'll be a couple of videos that will look and explicitly teach those concepts, and then we'll look at equilibrium, and then that will lead you into the questions.
Last season, Kevin Love led the NBA with over 1,100 rebounds. One of the keys to his dominance under the basket is the ability to box out opponents. Talk to me about your technique for boxing out.
I just try to play to my advantages and using leverage and using my body and my base to get that rebound.
Do you feel like you could box out anyone?
Yes.
But we didn't just bring in anybody. We brought in a 350-pound sumo wrestler. Before the clash of these titans, we wire Love up with science.
So I'm going to put 12 sensors all over your body. It's going to tell us exactly how much force you're generating to keep him out of the paint.
Much like boxing out a basketball player, sumo wrestlers use their mass to gain leverage on opponents. Our wrestler weighs almost 100 pounds more than Love, and being 10 inches shorter, he has a lower center of mass, giving him more stability and a built-in advantage over Love. Here we go. 3, 2, 1, go! As the wrestler comes in for the rebound, Kevin widens his base of support by bending his knees 75 degrees and keeping his feet 4 feet apart, effectively lowering his center of mass by nearly 35%. In simplest terms, the lower your center of mass and the wider your base of support, the more force required to knock you off balance. And by positioning his legs nearly perpendicular to the wrestlers, Love gains what's called rotary stability, the resistance against being knocked over. Extending his base of support toward the direction of the oncoming force actually increases Love's stability.
Biomechanics. Balance is about the body's ability to maintain the center of gravity within the base of support with as little sway as possible. Stability plays a crucial role in balance. Stability relates to the degree to which a body can resist being upset or moved. Many factors affect a person's stability. The first is the height of the body's center of gravity, which is an imaginary point around which our body weight is evenly distributed or concentrated. Finding our center of gravity is challenging because it shifts with movement. This means certain body types and postures are more stable than others. The lower the center of gravity, the more stable the body. So a person kneeling is more stable than a person of similar height standing, because the point at which all the body mass is concentrated is lower for the person kneeling.
Stability means that you have a center of gravity point, and you have been able to establish a base of support so that your center of gravity is in base of support.
In simplest terms, the lower your center of mass and the wider your base of support, the more force required to knock you off balance.
As our lucky last one is called line of gravity. So this means the vertical line which passes through the centre of mass to the ground. The line of gravity falls outside the base of support. You are relatively unstable. As you can see here, if I was to push that particular girl over, she would fall over straight away. Right, and as you can see, the lady on the far right, if the line of gravity falls within the object's base of support, equals more stability or increases the stability of that particular person.
Somewhere in a crowded room, empty little spaces. We'll get to our place. And someday, we won't talk of rain here. Oh, we'll get to our place. Someday, we'll get our heads out of the sand.
So the next concept we're going to look at is a state of equilibrium. So that relates a lot to balance of center of gravity and base of support, and looking at moving your way from that. So making sure equilibrium being when we're in a balanced state, and what happens and what sort of movements and shapes can move away from that state of equilibrium. So this is a reasonable video that explains that concept.
Today we'll be talking about equilibrium. Equilibrium can be broken down into stability, balance, center of mass, center of pressure, base of support, and ground reaction forces.
As Adriana is standing in anatomical position, her center of mass is at her belly button. The center of mass is her mathematical average of the weight distribution in her body, and her base of support lies around the perimeter of her feet. Her center of mass is therefore in the middle of her base of support. I was reviewing Adriana in the sagittal position. She moves forward onto the tiptoes, and her center of mass moves forward in front of her belly, and her center of pressure moves with the center of mass to keep her from falling forward. And as she lies back onto her heels, her center of pressure also follows the center of mass so that she doesn't fall backward. You see Jasmine in anatomical position. Her base of support falls around the perimeter of her feet, and her center of mass falls in the middle of her base of support. However, if her center of mass falls outside her base of support, she'll fall. In a wider stance, her base of support becomes wider and she is more stable. On one foot, she is less stable because her base of support is much smaller and her center of mass is more likely to fall outside of it. In the linebacker stance, she's very stable and her base of support is still very wide. This is used in sports like football and martial arts to face opponents head on without falling. Now that Jasmine is standing in anatomical position, she has a reasonably wide base of support. So if I were to push her, she's very unlikely to fall over. However, if she narrows her base of support and I push her, she's more likely to fall over. Now that Jasmine's standing in anatomical position once again, if I push her backward, she's pretty likely to fall backward because her center of mass is falling outside her base of support. But in a martial arts stance, she's still in her base of support if I push her backward, so she's less likely to fall over. Again, she's standing in anatomical position, but perhaps the most vulnerable position for anyone to be in when they're facing an opponent is to be on one foot. From pretty much any direction, she's likely to fall if I push her. Now Mariah is walking on the bench, and she has a very narrow base of support as she walks down the bench. However, if she tends to fall to one side, she'll throw her body in the same direction, forcing her trunk the opposite direction and keeping her balanced. On the left, we see Mariah. She's standing on the concrete. And on the right, Jasmine is standing in the sand. There are two different ground reaction forces at work here, and we're going to compare the two. Here we see Mariah on the concrete. Forces in this space. And on the sand will give more than the concrete does, which leads to less ground reaction force, making it slightly harder to do simple movements. Here we see Mariah and Jasmine doing the grapevine on the two different surfaces. As we said earlier, the concrete provides more ground reaction forces than the sand does, so the movements are slightly harder for Jasmine.
So now that I've gone through those two different concepts, what I'll need you to do is go through 7.6 and 7.7 and do the related questions, and then obviously next week we'll go through the concepts again to make sure we have that confirmed understanding.